Hi guys, so this is our math video for today. Today is March 27, 2020. It's Friday, and we've been doing a lot of work around the distributive property, partial products, and the area model. And I just want to highlight one student right now because he messaged me today on my teacher Facebook for Miss Maldonado CNCA. He sent me a picture of his own little poster he made in his notebook. And that's Martin Sarat from my class. So good job, Martin. I was really excited to see his work, and he wrote a really juicy statement. So today we're going to start to shift our focus a little bit. We will start with the do now to kind of review what we've been doing, but we are going to shift our focus back onto my favorite fractions. You know, if you're in my class, in Ms. Maldonado's class, I love fractions. And so we're going to dig deeper into fractions. Today's more of like a little bit of a review, and then in the next few videos, we're going to go deeper into fractions. So I'm excited about that. Make sure you take out your math notebook and your Bridges notebook because you're going to need it throughout the video. Let me share my screen so you guys can see what the learning intentions are and our vocabulary. All right, and let me just put this in present mode. All right, so remember, you can repeat after me at home. Today we are going to explore fractions on a ruler in order to determine equivalent fractions. I say you say equivalent fractions. Success criteria, I can compare two fractions and determine which one is greater, less than, or equivalent using different models and claims. Language intention, I use words from our fractions anchor chart, which we're going to go over right now in a second. And social intention, I do the work even when no one is looking. And so we're going to start with actually our anchor chart for, actually we're going to go to our anchor chart for fractions in a little bit. We're actually going to go back a little bit and do a little review of what we've been doing, and then we'll start with our fractions work. So for our do now, I featured Ms. Carrillo. Ms. Carrillo says that the distributive property states that a combination like 4 times 18 can be written as 4 times 10 plus 4 times 8. Do you agree or disagree with Ms. I made a mistake. I meant to say Ms. Carrillo here as well. Do you agree or disagree with Ms. Carrillo? Can you represent her statements with an area model? So I'm going to ask you to pause in a moment, and I want you to write a statement. I agree or disagree with Ms. Carrillo because, is she correct? You know, she's saying, Ms. Carrillo is saying that the distributive property states that a combination like 4 times 18 can be written as 4 times 10 plus 4 times 8. Explain why, if you do agree, and then you can you represent it with an area model? Pause me now to go do that. All right, you're back. So I am going to annotate. I'm going to write on the screen. So I'm going to start with maybe our statement, right? So do I agree or do I disagree with Ms. Carrillo? Well, I think, or I'm going to say I agree with Ms. Carrillo because a combination like 4 times 18 can be represented, let me make this wider, can be represented as 4 times 10 plus 4 times 8 because she decomposed the 18 into a 10 and a 4 in order to be multiplied. I'm sorry, a 10 and an 8 in order to multiply by the factor of 4. Okay, she's using, I'm gonna use some juicy words. She's using partial products in order to get the total product, and the distributive property is an efficient strategy. Let me just read that again and see if what that sounds like out loud. So I agree with Ms. Carrillo because a combination like 4 times 18 can be represented as 4 times 10 plus 4 times 8 because she decomposed the 18 into a 10 and an 8 in order to multiply by the factor of 4. She's using partial products in order to get the total product, and the distributive property is an efficient strategy. I'm just going to make this a little bit smaller. Let me see if I can. Looks like I can't. All right, that's okay. I'm now going to represent this with an area model. Like, how did she do that? Well, I'm going to draw a rectangle first. So I'm multiplying, I know I'm multiplying 4 times 10. And then I'm going to grab another color so I can really see it. And then 4 times 8. So that's not going to be as long as my 10 one. And I'm going to label it. So 1 second as I'm labeling. Let me see. I'm going to make my line a little bit thicker, and I'm going to use a blue. So she multiplied, right, 4. That's going to be my height of my area model. And then she multiplied 4 times 10. And then she multiplied 4 times 8. And how does this area model represent 4 times 18? Well, this is the 4, and I'm multiplying 10 and 8, right? That's 18. I'm just decomposing it to find our partial products, right? So that it's easier to find the total. And we decompose into numbers that are friendly to multiply by, because we know what 10 times 4 is, right? 10 times 4 we know is 40. And 4 times 8, if we already know our multiplication facts, our multiples of 4, multiples of 8, we know 4 times 8 or 8 times 4 is 32. So here we have our I say, you say partial products, right? That's part of our total, partial because it's part of our total product that we're about to get. So now I have to add my 2 products together. 40 plus 32, that's going to give me 72. Ooh, and that is an ugly 72, so give me a second while I fix that. Let me fix that 72 really fast. Okay, and so our total product is 72. Therefore, 4 times 18 equals 72. If you need to pause to write any of this down in your math notebook, if you made a mistake, do it now, right? This is for you, so make sure you fix it in your notebook. And we're back. Okay, so I'm gonna clear this, and now we're gonna go into our fractions vocabulary, which I'm so excited about because I love, 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 love fractions. Give me 1 second. Clear all drawings, and now our next page. All right, so here we go. We're gonna remember, if I say the word, you say the word at home, and you can do the gesture with me. We're gonna start with, imagine this is my fraction, this is the line, numerator, denominator. Benchmark fraction, 1/2. Remember, 1/2 is like our best friend in the fraction world because it really helps us figure out if fractions are less than 1/2 or greater than 1/2. We have part whole, right? So when I think of numerator and denominator, I think of the number of parts and the total number of parts, right? The total whole. We have equal parts, we have equivalent, we have greater than, right? We have less than, and that might be weird flipped around, so just make sure you look at my chart so that you can really see the difference between greater than and less than. Equal to, we have a bar model, we have a pie model, we have a number line, unit fractions, right? Any fraction that has 1 as a numerator, fractions greater than a whole. We've talked about those fractions in the past, especially when we were looking, I think, at Kit Kat bars. Now, our models and strategies and claims, I love my claims. We're gonna start with pie model, which is a great model for us to utilize when we're comparing fractions. However, it can be a little tricky sometimes if you're not partitioning the circle or the pie correctly, right? And so we've talked about that a lot. That's important. When we're modeling, we need to make sure that we're demonstrating equal parts. Same with the bar model. If we're comparing side by side, we need to make sure that we're partitioning. Each part is equal, because if not, when you're comparing, it's not gonna come out correctly, right? Number line model, and then our claims, those are kind of hard to see, so I'm gonna read them out loud to you. Claim number 1, when the numerator is the same, look at the denominator. The smaller the denominator, the larger the piece out of the whole. So 1/4 is less than 1/2. Claim number 2, when the denominator is the same, look at the numerator. The larger the numerator, the more pieces out of the whole. So 1/4 is less than 3/4. I'd rather have 3/4 of a chocolate than 1/4 of a chocolate. Claim number 3, when the numerator and the denominator are the same, the fraction is equivalent to 1 whole. So for instance, we have 4/4 is the same as 1 whole. 3/3 is the same as 1 whole. Claim number 4, when the numerator is greater than the denominator, the fraction is greater than 1 whole. So we saw that if it's 5/4, we know that that is greater than 1 whole, right? If I have 2 Kit Kat bars and they're both partitioned into those 4 pieces, and I say, hey, I ate 5/4 of Kit Kat bars, that means I ate 1 whole Kit Kat bar and 1/4 of the second one. So now we're gonna move on to our problems and investigation. So right now, all I want you to do is a lot of thinking. I will ask you to write in a little bit, but right now I just want you to think. So take a look at our screen. I just want you to notice a few things. Look at the picture. We have a long stick of licorice, we have a ruler, and then we have something right below that ruler. And it says 1 foot is the same as 12 inches. We've used those rulers before in class, and that is equivalent. 12 inches is the same as 1 foot. Now, I'm gonna read this out loud to you guys, and I really want you to think about what I'm asking you. If I'm splitting this licorice stick with Miss Carrillo, what fraction of the licorice stick could each of us get? How many inches would she get to eat? How many inches would I get to eat? So look at the licorice and how I have it lined up with the ruler. And so we're gonna use that as a model today, which is really kind of looks like a number line, right? So look at that licorice. If I had to share with Miss Carrillo, what fraction of the licorice stick would I get and what fraction would she get? How many inches of the licorice would she eat? How many inches of the licorice stick would I eat? So I'm gonna ask you to type the following. Both Miss Carrillo and Miss Maldonado would both get of the licorice stick, which means they each would get inches to wolf down. All right, let me just move this a little bit this way so you guys can see it better. All right, write it down. So both Miss Carrillo and Miss Maldonado would both get of the licorice stick. So what fraction? You're gonna write the fraction on that first line. The licorice stick, which means they would each get inches to wolf down. So pause it now so that you can answer in your math notebook. And you should be back. So both Miss Carrillo and Miss Maldonado would both get. Hopefully you had an opportunity to write that down and to figure it out. I'm gonna use my other pen so I can do this. I'm gonna use black this time. Well, I'm looking at the ruler and I'm like, well, I know if it's between me and Miss Carrillo, I'm gonna share it between 2 people, which means I would get a half and she would get a half. And if I look at the ruler, I see that there's a total of 12 inches. And if I have to split that right down the middle, that means I would split it at the 6 because 6 plus 6 is 12, right? 6 is half of 12. So Miss Carrillo would get, both Miss Maldonado and Miss Carrillo would both get half of the licorice stick. And that's a really bad half, guys. So hold on a second. Let me fix that really quickly. See if it lets me. Hold on 1 second while I fix that. I think this is too big. Let's make this size 15. Nope, that's too big. Size 15, there you go. All right, so we're back in business. So both Miss Carrillo and Miss Maldonado would get half, right? Would both get half of the licorice stick. And let me just make this a little bit better so you can get it, so you can see it. And I'm gonna just write it again. So both Miss Maldonado and Miss Carrillo would get 1/2 of the licorice stick, which means they would both get to wolf down. How many inches? Well, if I'm looking, 6 inches, right? So I get 6 inches and she gets 6 inches because that's 12 inches total. Would wolf down 6 inches of the licorice stick. I'm looking, so she would get a half and I would get a half. There's another fraction that I could write because it's partitioned into 12 parts. So she would get 6, or, so I would either get 1/2 or 6/12 because those fractions are equivalent, right? 1/2 and 6/12, right? If I look at the ruler, there's 12 total parts. That's how the ruler's been partitioned. And if I get half, that's 6 out of the 12. And so, oh, and 1 is half of 2 and 6 is half of 12. So that makes sense, right? Now we're gonna try it with a few different ones. I'm gonna clear this page, pause it if you didn't get that before and write it down in your math notebook. If you did get it right, give yourself a big check mark, right? All right, so I'm gonna clear it now. Clear all drawings. And now let's go, oops, I'm like writing all over this now. Clear all drawings and then mouse. Yep. And it's not letting me. There you go. All right. So now we're going to do the second one. If I'm splitting this licorice stick with Miss Carrillo and Mrs. Alonso, what fraction of the licorice stick would each of us get? How many inches would Miss Carrillo get to eat? Mrs. Alonso, how many inches would I get to eat? So instead of sharing between 2 people, now I'm sharing, it's gonna be between 3 people. I want you to look very carefully at that ruler. And can I partition that licorice stick into 3 parts, into thirds? Do that now. And you're back. Okay, so I'm looking at that ruler, I'm looking at that licorice stick. Can I partition or divide that licorice into thirds? Well, let's see. I know there's 12 inches in total, and I have to divide it between 3 people. Let me write that down so I don't forget. So I know I have 12 inches in total, that licorice stick, and now I'm sharing between 3 people because it's me, Miss Carrillo, Miss Alonso. I know I can use my multiplication facts. 3 times gives me 12. So 3 friends times how much will each friend get? What's the group size, right? And 12 inches in total of a licorice stick. Oh, must be 4 inches. Well, let me just double check. I'm gonna use a different color. So let me partition at so I'm gonna partition it into thirds, which means each person is going to get 4 inches. Let's see if it looks correct. So that would be maybe my share, this would be Mrs. Alonso's share, and that would be Mrs. Carrillo's share. Does that look like equal parts? Yes. So that means that Mrs. Alonso, Miss Maldonado, and Miss Carrillo would each get a third of the licorice stick, or let's see. Right? If it's partitioned into 12s, what's another fraction that's equivalent to a third? So I know my whole, the whole's been partitioned completely into 12 parts, and each person got 4 inches. So really each person got 4 12s. Does that make sense? Yeah, that totally makes sense. So like I got 4 12s, Miss Alonso got 4 12s, Miss Carrillo got 4 12s, or we each got 1/3. Both those fractions are equivalent to one another. And each person got how many inches? We each got 4 inches from the licorice stick. Thumbs up if you understood that. Now we're gonna do a few more together. So clear all drawings and then mouse. All right, and this is going to be, we're gonna have a few more that we're gonna do together. So this one's a little bit different. I want you guys to pause this video right now so that you can copy this down in your math notebook. So you're going to write this table down where it says between number of friends, fraction each friend would get, how many inches would each friend get? And we have 3 options, and we're gonna do all 3. 4 friends, 6 friends, 12 friends, fraction each friend would get, how many inches would each friend get? You're gonna do it with me in your notebook as I do it. Pause me so that you can do that now. All right, we're back, guys. And so here we go. Let me see if I can move this a little bit because it's in my way. Okay. So now instead of 3 friends, I'm sharing with 4 friends. I am looking and I see that I have 12 inches, right? So now I have to share with 4 friends, 12 divided by 4. 12 divided by 4. If I have to share with 4 friends, that means that you would each get 3 inches of the licorice stick. So I'm gonna use a different color so you guys can see it. Use brown. So let's say it's between me, Miss Alonso, oopsies, between Miss Alonso, Miss Maldonado, Miss Delgado, and Miss Carrillo. So I'm gonna use a different color so you guys can see that. So we would each get 3. We would each get 3 inches of the licorice stick, which means fraction each friend would get, they would either get, well, if I look at it, it's divided into fourths, and we would each get 1/4, or, yeah, say it at home, or 3 inches out of 12 inches. So 1/4 is the same as 3/12. Do you guys see that? Okay. Now, how many inches would each friend get? We just said it. We would each get 3 inches because there's 4 friends, and each friend would get 3 inches, which gives us a total of 12 inches. Let's do a different color for 6 friends. Let me use a different color. Let's do blue this time. So I'm gonna erase, no, I'm gonna keep it so you guys can see it. So now between 6 friends, now I have to divide this. I have 12 inches in total, and I have to divide it or share it between 6 friends. So 12 divided by 6 would mean that each friend would get 2 inches. So I'm gonna go in with my blue. So that's 2, 4, oof, that was bad. Let me fix that. I'm just gonna overlap with the other one, 6, 8, 10, 12. So 1, 2, 3, 4, 5, 6. So I'm sharing with 6 friends, which means that each friend got 2 inches. And so if I look at it now, I have 6 parts. So each friend got 1. Yep. 1, 2, 3, 4, 5. Each friend got 1/6 of the licorice stick, or 2 inches out of the 12 inches. Those are my 2 fractions that are equivalent. And I already know how many inches each friend would get. They would each get 2 inches. Let me just write inches so we don't forget. IN for inches. Okay, so you guys don't get confused. I'm gonna do another erase. I'm gonna erase this so you guys can see what happens when we share with 12 friends. All right, so 12 friends, and there's 12 inches of licorice stick. So 12 divided by 12. If I look at the ruler and my licorice stick, 12 friends sharing 12 inches of a licorice stick means that each friend would get 1 inch of a licorice stick. So I'm gonna use a different color again. I'm gonna use green. And let's use my drawing. So that'd be 1 part, 2, it's not gonna be perfect, 2 parts, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so 12 friends, right? I see that they each would get 1/12. Yeah, they would each get 1/12 of the licorice stick. And so how many inches? They each got 1 inch. All right, write that down. If you need to pause it right now, pause it and write it down in your notebook. We're gonna do one more together and then you're gonna have some independent practice time. And you should be back. So let me clear all of my drawings and let's go to the next page together. All right, so it's kind of hard because you guys don't have these little rulers. I would have wanted to print this for you guys in class so that you could see it, or we can use a ruler to compare it, but that's okay. So we're going to find equivalent fractions using a ruler. For the first question we have, how many 6 will make a third? So first of all, let's go to the first ruler and we're going to divide it into 6 parts. So I already know 12, let me go back. 12 divided by 6 is 2 because we did that earlier. So let me use another color. Let me do dark green this time. And let's do, let me see, draw. Let's do draw. Oh, that one's too thick. Okay, so 12 divided, I want to divide it by 6, right? So 12 divided by 6, which means that that would be divided into, each person would get 2 parts. 3, and let me just double check. 1, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. And then how many, the question is, how many 6 will make a third? So I'm gonna use the second ruler to compare, to make thirds, and then figure out, well, how many 6 would make a third? So I'm using the same color. So now instead of dividing it by 6, 12 divided by 6, I'm gonna divide 12 by 3. So 12 by 3 would mean 4 parts. So that's 1, yep. 12 divided by 3 would mean that each section would be 4 inches. And yeah, so now I see I have thirds now. I have 1/3, 2/3, 3/3. And now the question that it's asking me, I'm gonna use a different color so you guys can see it. The question that is asked, the question that's being asked is how many 6 will make a third? How many of these are the same as 1/3? Well, I see that this is 1/3, and if I compare it, it looks like 2 6 is the same as 1/3. And I'm gonna write that down so you guys can see it in a different color. And let me see. So we said 1/3 is the same as 2 6. All right, and it's true because if I double the 1/3, if I double 1, right, I multiply by 2, it gives me 2. If I multiply 3 by 2, it gives me 6. So I know that those two fractions are equivalent. My second question, how many fourths will make a half? Well, making a half is easy, 1/2, right? So I'm gonna use another color so you guys can see it. 1/2, if I 12 inches, I divide that by half, that means that that would be right at the 6-inch mark. And then my question is, how many fourths will make a half? So now for my second ruler, I'm dividing it into fourths. So 12 divided by 4 would mean that each person would get 3 inches of a licorice stick. And now if I compare it, I'm gonna use a different color this time. Let's see. I'm gonna use a different, let's use pink this time. So this is a half, right? This is a half. Well, how many fourths will make a half? I see 2 fourths is the same as 1/2. And let's use a different marker so you guys can see that. So 1/2 is equivalent to 2 fourths or 2 quarters, right? How do I know that? Because 1, look at the relationship between the numerator and the denominator. 1 is half of 2 and 2 is half of 4. And so we have equivalent fractions there. Our next set of questions, our last set, how many 12s do you need to make a fourth? Okay, So let me divide one of my rulers in fourths again, which we already did, and we saw that each part would be 3, right? So let me do that again, 3, my 3 parts, here are my fourths again, and how many 12s do you need to make 1/4? So I'm gonna shade that in with another color and use a different marker so you can see it. So I'm trying to figure out how many 12s would make 1/4. So now I have to divide my fraction, my ruler down here into 12s, which means that 12 inches divided by 12 would mean 1, right? 1 inch. I'm going to section it off by 1 inch. Let me use a different color for that. And this one, so I'm going to split it like that. By inches, 4, 5, 6, 7, 8. It's not, my lines are not going to be perfect. 9, it's kind of hard to do this on the laptop. 10, 11, and 12. And now I want you guys to think, pause right now. How many 12s make 1/4? What fraction with the denominator of 12 would be equivalent to 1/4? Go do that right now. Okay, you're back. If you said, let me use a different color. If you said, right, I'm going to shade it in. If you said 3/12 is the same as 1/4, you are correct. Let me write that down with another color so you guys can see it. So we said 1, ooh, that's not the one I want. So if you said 3, yeah, if you said, actually, I'm going to erase that. That's not what I meant to write. Because we divided that into fourths. If you wrote that 1/4 is the same as 3/12, you are correct, right? We see that those using that number line, it's almost like a number line, right? Using the ruler, we saw that 1/4 is the same as 3/12. So the last part for today's lesson, my friends, we've done a lot of equivalent fractions before and comparing fractions. This is just kind of a review because in the next few lessons, we are gonna go a little bit deeper. So just watch out for that. Let me clear this. Let me see, why is it not showing up? Okay. All right, so let me just clear this really quickly. Clear all drawings. So this is your independent practice for today. I'm pretty sure most of you haven't done this page, but if you have, just go over it, see if you made mistakes from before. My class might have done this during the day that I wasn't there, maybe with the sub, but if you didn't do it, this is your opportunity to practice and compare some fractions. It's on page 129. I look forward to our class on Monday. We're gonna go deeper into fractions, so I'm looking forward to seeing some awesome comments. If you have any questions, make sure your parents message me. See you in the next video, friends.